This lesson is about the general features of the XRF spectrum. First observation is that in the XRF spectrum we expect for each element to find more than one peak. So, for example, here we have the spectrum of tin. We see K alpha, K beta, and we see the L alpha and L beta. There are two things to take into account to explain why we have more than one peak. The series probability means basically that when we have the photoelectric effect, so the electron is kicked off from the K shell, this shell can be filled by an electron coming from the L shell or from the M shell. Of course, this phenomena will produce the K alpha and the K beta, like in this case. This transition, K alpha or K beta, have a ratio about 1 to 5. So, if there is the K alpha, the K beta will be 5 times smaller. For the other lines, like L alpha, L beta we see over here, L alpha, L beta, they are almost the same. L gamma will be generally much smaller. Another effect to take into account is the cascade effect. When we have that a K electron is kicked off, the K electron will be filled by the L or the M electrons. But then what happens is that if is the L electrons that fill the K shell, here we will have another vacancy that will be filled by other lines. There is this cascade effect that will produce the other X-rays for the other lines, basically. So in general we expect when we have this, for example, pure element like tin, we are going to see this kind of spectrum where we have the K alpha, K beta, and then we have the L alpha and L beta. A last observation, general observation about the XRF spectra is the way how we visualize them. The most common would be to use this linear y-axis. So basically on the left, on the y-axis, we have the counts, how many of these X-rays have been counted, measured. So generally we will have most of the time linear scale, so just a normal scale. This linear scale is fine, we see the intensity of the major strongest line, but if we are interested to the low intensity lines, like for example L alpha, L beta, it makes more sense to work with a logarithmic scale. In this case, you see, it's like the strongest peak, K alpha and K beta over here, they are compacted, and the L alpha and L beta becomes much more visible. So this is definitely the logarithmic scale. It's something you want to try in order to be sure that you don't miss the weak lines in your spectrum.